Bismillahirrahmanirrahim. Assalamu alaikum, dear students. This is our next problem. Problem having been chosen from the book Modern Physics by Stephen T. Thornton. As usual, we first come to its statement. Okay. How large an error in percent in the velocity do we make by treating the velocity of a 7.7 million electron volt alpha particle non-relativistically. Okay, dear students, actually in this problem we have to compare velocity classically and velocity relativistically. Similarly, some more things need to be compared in these two different systems. Okay, that is a classical and Newtonian. For example, in classical and Newtonian, kinetic energy is K equal to half mv square, while in relativity kinetic energy is in terms of gamma Lorentz factor and speed of light c. Anyhow, we will deal with such things in quite detail. Before starting our solution in a proper manner, we have to go through a few snapshots which we will provide a foundation for our solution. Okay. First snapshot is about kinetic energy as being calculated in Newtonian mechanics or classical physics, classical mechanics. Okay. The kinetic energy of a particle of mass m moving with a speed v is k triple parallel lines. K is equal to half mv square. Okay. Actually, these three lines symbol is in the sense of is defined as or is equivalent to. Okay, so it does not make very much difference whether we use exactly sign of equality or these three lines. Okay, kinetic energy is equal to half mv square. Next, dear students, there is a table. Okay. Next, there are three more snapshots. Okay, in the next snapshot, a table has been shown. Table is some particle masses. Okay, this table deals with the masses of various particles like electron, proton, neutron, deuteron, alpha. Okay. Here we are concerned with the mass of alpha particle. Okay. So, dear students, mass of alpha particle in terms of kilogram is this, which we will not use in this problem, and in terms of million electron volt over c square, it is 3727.3792 million electron volt over c square. Okay. This last value, fifth value regarding alpha particle will be used in this problem, which means mass of alpha particle in terms of million electron volt over c square is 3727.3792. Next snapshot is about Lorentz factor gamma. Gamma is equal to 1 over 1 minus u square over c square, where u is the speed of one frame of reference relative to another, and c is the speed of light in vacuum. Gamma is called a Lorentz factor, and this Lorentz factor is very plays a very basic role in relativity. Okay, dear students, next snapshot is about relativistic kinetic energy. Okay, relativistic kinetic energy, capital K, or sometimes we may also denote it by capital E with capital K as a subscript of E. Okay, relativistic kinetic energy K or capital E with capital K as a subscript of that E. Okay, relativistic kinetic energy K is equal to mc square over under root 1 minus v square over c square minus mc square, and this alternatively becomes equal to gamma minus 1 mc square, where v is the speed of particle, c is the speed of light in vacuum, and gamma is the Lorentz factor relating rest frame of particle and frame of observer. We have dealt with this gamma in detail in the above snapshot. Okay, now we come towards our solution in a formal manner, proper manner. Okay, using kinetic energy equal to half mv square, that is, this kinetic energy is Newtonian or classically determined. Okay, kinetic energy equal to half mv square. This implies that kinetic energy is actually given in the problem, which is 7.7 million electron volt. In place of kinetic Ke, we have used this value which is provided in the statement, and in place of m, we have used the value given in mass of particles, in which alpha was mentioned in the last row. Okay, mass of an alpha particle is 3727.3792 million electron volt over c square, and we have not disturbed v square because we are going to determine the value of v. Okay, actually, dear students, in such situation we can reformulate this expression as v square equal to 2 into kinetic energy over mass. Okay, and then we will take under root of left hand side, both sides, then v will become equal to 2 into kinetic energy divided by m whole under root. Okay, anyhow, we have not used this trend, we have put these values in this way. Okay, now v square will become equal to this. Okay, half into this. Okay, what we have just simplified. Okay, v square is on this side, and 2 will be multiplied with this value, and this value will be divided by this value, and c square will become in the numerator, million electron volt will become in the denominator, then this million electron volt will be cancelled with this, and v square will become equal to this. When we will take under root of on both sides, we will get v equal to 0.064 c. Okay, we can also write it as v over c equal to 0.064. We can also write v over c as beta. Okay, because we know that beta is speed parameter. Okay, so it does not make any difference whether we write v as this or v over c equal to 0.064 or beta equal to 0.064. Okay, now we move forward. Okay. Now Lorentz factor gamma is equal to this over this. Okay, in place of v we have used the value which we have calculated above. Okay, here c square will be cancelled with c square and we will get Lorentz factor gamma equal to 1 over 1 minus 0.004, and this alternatively becomes equal to 1 over under root 0.996, and this alternatively becomes equal to 1 over 0.998, and this alternatively becomes equal to 1.002. Okay, so our Lorentz factor gamma has become equal to 1.002. Okay, now we know that relativistically kinetic energy is equal to gamma minus 1 mc square. Okay, now we go back to this snapshot. Okay, relativistic kinetic energy equal to this minus this, or this equal to this. Okay, so here we have used this expression, and by using this expression our relativistic kinetic energy becomes kinetic energy E with K written as a subscript of E. Okay, usually in classical physics kinetic energy is usually not denoted in this format, in this form. This form is usually restricted to relativistic expression. Okay, anyhow, it is not a very a rigid classification. Usually it happens that kinetic energy in this shape is written only in relativistic side. Okay, sometimes might be on classical side. Now, okay, kinetic energy equal to this minus this into mc square. Lorentz factor gamma we have found in the previous step, which is equal to this, and from the table of masses of particles, mass of alpha particle in terms of million electron volt over c square is given as this. Okay, and from that m becomes equal to this. Okay, so a simplification of the above step shows that kinetic energy AEK becomes equal to 7.45 million electron volt. Okay, actually dear students, we have not to find out this, but we see that one kinetic energy is 7.7 million electron volt, and this is 7.45. Okay, one value is 7.7, 7.70, and other is 7.45. Okay, actually we are making a comparison or between relativistic and classical expressions. Okay, now gamma is equal to this 1 minus mu square over c. We know that this is denoted by speed parameter beta. If we replace it by beta square, then 1 minus beta square will be shifted to other side, and 1 over gamma will be shifted on right hand side, and it will become in the denominator. Then we will take square of both sides, and hence 1 minus beta square will become equal to this, and hence beta will become equal to 1 minus 1 over gamma square. We have already found the value of gamma. If we use gamma 1.002, then its square will be equal to this, and when we divide this value by 1, we will get 0.996, and when we subtract this value from 1, we get 0.004, and when we take under root of this value, we get 0.063. We know that beta is a speed parameter, which is v over c. So we can once again replace beta back by v over c. When we replace beta by v over c, then this implies that V will become equal to 0.063C. Okay, dear students, on one we once again go back and see previous value of V. So previous value of V was 0.064C. Okay, one value. Dear students, here we have found one value of kinetic energy 7.45 and one value of kinetic energy 7.7. So similarly, one value of V is 0.064C, while other value of V is 0.063C. Okay. Now V equal to 0.064C classically, 0 V equal while V equal to 0.063C relativistically. This implies that this minus this multiplied by 100 is equal to 0.1%. Okay, so 0.1% is our answer, is our solution of the problem. Dear students, despite the fact that I have solved this problem completely, I am not fully confident about the accuracy of this problem. If you find any deficiency in this way of solving, you can guide me through comments on YouTube. Okay. Anyhow, according to my knowledge, I have tried my best to solve this problem as accurately as I can. Okay, if some deficiency is found and you observe some deficiency in the solution of this problem, then you can please guide me by giving your feedback through your kind comments. Okay, this is the end of our problem. This is the end of our video. Till next video, Allah Hafiz.